Welcome to this explainer. If you're a developer building AI context integrations, you already know how absolutely crucial a rock-solid protocol is. Well, today, we are breaking down the massive 2026 0728 Model Context Protocol release candidate. We're going to decode the new architecture and figure out exactly what this leap forward means for your codebase.
So we're looking at literally the biggest revision since MCP first launched. It's a fundamental shift. We're moving away from those slightly clunky, experimental early days and stepping right into true enterprise scalability. The entire focus right now is making this protocol hum beautifully on ordinary commodity HTTP infrastructure.
Here's our roadmap for today. We'll start with the big revision and the new stateless protocol core. Then we'll hit first-class protocol extensions, talk about how they're hardening auth and schemas, and wrap up with the new evolution and deprecation policy.
All right, Section 1, a stateless protocol core. We are officially ditching the baggage of the past.
Remember what this looked like before late 2025? Running a remote MCP server was honestly a bit of a beast. You had to deal with sticky sessions, shared session stores, and even deep packet inspection just to get your routing right. Now, it is pure freedom. Any request can hit any server instance using plain, round-robin load balancers. I mean, this is the kind of horizontal scaling developers dream about.
To actually pull off this stateless magic under the hood, the old initialization handshake is just gone. No more bouncing initialize and initialize messages back and forth. That emp session ID header? Tossed out. Instead, the whole thing relies entirely on standard HTTP headers, like emp method and emp name, to route your operations. Your protocol version and client info, they just hitch a ride in the metadata of every single request. But hold on, this brings up a huge question. We are building AI applications that absolutely require context across multiple turns, right? So how on earth do we maintain application state if the protocol itself is washing its hands of managing sessions?
The fix here is something HTTP APIs have used for decades, the explicit handle pattern. You just mint an explicit handle, say something like a basket_ID, and hand it to the model. The model then just threads that identifier right back through any subsequent calls as a completely ordinary argument. It makes your state visible and highly composable instead of hiding it away in transport metadata. It's actually a much cleaner paradigm.
Okay, but what happens mid-call? Without a persistent connection holding the door open, how does the server pause to ask the client for something? Like, what if you need to throw an elicitation prompt to ask the user to confirm a file deletion before proceeding?
Enter the input required result. This is such an elegant solution. Instead of trying to hold open a server-sent event stream, the server simply drops this payload. The client pauses, gathers the answers from the user, and then completely reissues the original call, packing in the new input responses along with an echoed request state. Because everything is neatly packaged in that payload, literally any server instance in your cluster can grab that retry without missing a beat. And because all of this traffic is now stateless, it becomes wildly cacheable. List and resource reads now carry TTLMS and cache scope parameters, which are modeled right off standard HTTP cache control. Plus, it's totally traceable now. The spec officially integrates the standard W3C trace context directly into the metadata. This means you can track a tool call from your host app straight through the SDK, the server, and all the way downstream as one single beautiful span tree in your OpenTelemetry backend.
Moving right along to Section 2, first-class protocol extensions, and a new formal process for capabilities.
So experimental features used to just kind of float around in the core spec. Not anymore. The new extensions framework gives us a formal, predictable lifecycle. Extensions get their own clean reverse DNS IDs. They're negotiated up front in a capabilities map, and crucially, they version completely independently from the core spec. This means the core protocol stays super lean, while you can still have rapid, wild innovation happening in separate repositories.
A prime example of this graduation path is MCP apps. It's officially an extension now, and it is a total game changer. It lets your servers ship highly secure server-rendered UIs straight into host environments. Tools just declare their UI templates ahead of time, hosts can review and cache them, and then they render safely inside a sandboxed iframe. And every single action initiated by that UI, it routes through the exact same JSON RPC, audit and consent path as a regular tool call. Speaking of things graduating, let's talk about the tasks capability. It has officially moved out of the experimental core and is now a dedicated extension. Now, a quick heads up. If you were messing around with the experimental tasks API back in late 2025, you're going to need to migrate. It's been totally rebuilt around this new stateless model. Task creation is server-directed now, and the client drives the whole thing using task/get, task/update, and task/cancel. It's just a way more bulletproof lifecycle.
All right, Section 3, hardening auth and schemas for real-world enterprise deployments. They're really battening down the hatches for enterprise use. To shut down complex mix-up attacks, where bad actors try to confuse clients across massive, multi-server setups, validating the IS parameter from RFC 92007 is now completely required. We're also getting a huge upgrade to JSON Schema 2020-12 for tool inputs and outputs, which unlocks complex composition and conditional logic. Oh, and missing resource errors? Those have been swapped from a custom code over to the standard JSON RPC invalid params code, which is -32602. It's all about playing nice with modern standards.
And finally, Section 4, the evolution and deprecation policy, how we're building for the future. Look, with any massive upgrade, you're going to leave some things behind. But everything deprecated here has a clear, scalable replacement. Roots are out, replaced by standard tool parameters, resource URIs, or config. Sampling is now pushed to direct integrations with your LLM provider APIs. And logging is moving on up to open telemetry for structured observability. Or you can just use standard error for the basics. Now, before you panic and think you have to rewrite your entire codebase by tomorrow morning, take a breath. These are strictly annotation-only deprecations right now. The new feature lifecycle policy guarantees a strict path, active, then deprecated, and finally removed, with an absolute minimum of 12 months between deprecation and removal. So, whatever methods and types you're building with today, the spec guarantees they will keep working for at least a full year.
The maintainers really hit the nail on the head here. They noted that this release gives MCP the foundation it needs to grow on for a long time. They're making a clean break today to ensure a totally predictable foundation for tomorrow. By ripping off the Band-Aid and removing those complex stateful mechanics now, future revisions can evolve without breaking the core stuff you rely on.
Which brings us to the most exciting part of all this. Now that the absolute headache of managing complex session state is totally out of your way, and you can just deploy on standard horizontal HTTP infrastructure, how are you going to use this lightning-fast foundation to scale your next big AI idea? The tools are all there, the old bottlenecks are gone. I absolutely cannot wait to see what you build with this. Thanks for joining me on this explainer, and happy coding!